Welcome to Attarashi Hinode by T3 Solutions. Today we are going to learn about properties of whole numbers. Before that, what are whole numbers? Numbers used for counting the objects are called natural numbers, and natural numbers along with zero form the collection of whole numbers. This is the representation of whole numbers on a number line. Now let us go to the properties. In this video, we are going to learn the first three properties, that is closure property, commutative property and associative property. The remaining properties we will learn in the next video. The first property is closure property. Let us check the property for all the four arithmetic operations. First one is addition. We know 2 and 3 are whole numbers, and when we add 2 and 3 we get the sum 5. 5 is also a whole number. Also 7 and 3 are whole numbers. 7 plus 3 equal to 10. 10 is also a whole number. That is, when we add two whole numbers, the sum we get is again a whole number. So we can say whole numbers are closed under addition. In general, if A and B are two whole numbers and A plus B equal to C, then C also will always be a whole number. Next is subtraction. Here 4 and 1 are whole numbers and 4 minus 1 equal to 3. It is also a whole number. But what about 2 minus 6? 2 minus 6 equal to minus 4. It is a negative number. So it is not a whole number. That is, even 2 and 6 are whole numbers. The difference got is not a whole number. So we can say whole numbers are not closed under subtraction. So in general, if A and B are two whole numbers, then A minus B equal to C will not be a whole number if A is smaller than B. When we multiply the whole numbers 5 and 4, we get the product as 20. 20 is also a whole number. Here 2 into 8 equal to 16 and 2, 8, 16 all are whole numbers. That is, when we multiply two whole numbers, the product we get is also a whole number. Here we can say whole numbers are closed under multiplication. When we divide two whole numbers, the quotient need not always be a whole number. In the first case, when we divide 9 by 3, we get the quotient as 3 and 3 is a whole number. But when we divide 6 by 5, we get a decimal number. So whole numbers are not closed under division. Here we can say whole numbers are closed under addition and also under multiplication. Next is commutative property. We can add two whole numbers in any order. For example, 4 plus 5 equal to 9. 5 plus 4 is also 9. Even when we change the order of the numbers, here we got the same answer. So addition is commutative for whole numbers. In general, if a and b are two whole numbers, then a plus b equal to b plus a. It is the same for the multiplication also. We can multiply two whole numbers in any order. But for subtraction and division, if we change the order of the numbers, we get different answers. So, subtraction and division are not commutative, while addition and multiplication are commutative for whole numbers. Third property is associative property. Here I have taken three whole numbers 2, 3 and 4. In the first case I have grouped 2 and 3, that is 2 plus 3 equal to 5, then plus 4 equal to 9. In the second case I have grouped 3 and 4, that is 3 plus 4 equal to 7, then plus 2 equal to 9. In both the cases we get the same answer. That is, when we add numbers, we can group the numbers in any way. The grouping of the numbers does not change the sum of the numbers. So we can write 2 plus 3 plus 4 is the same as 2 plus 3 plus 4. That is, in addition of whole numbers, the sum does not change even if the grouping is changed. Associativity holds true for addition in whole numbers. In general, if a, b and c are three whole numbers, then a plus b plus c equal to a plus b plus c. Same is for the multiplication also. If a, b and c are three whole numbers, then a into b into c equal to a into b into c. But for subtraction and division, when grouping is changed, we get different answers. Let us check for subtraction. Here the three whole numbers are 10, 6 and 2. First 10 and 6 are grouped. So 10 minus 6 equal to 4. Then again minus 2, that is 4 minus 2 equal to 2. Here 6 and 2 are grouped and 6 minus 2 equal to 4. Then 10 minus 4 equal to 6. Here the answers are different. Same is the case for division also. Here the whole numbers are 18, 6 and 3. 18 and 6 are grouped here. So 18 divided by 6 equal to 3. Then divided by 3 equal to 1. Here 6 and 3 are grouped. So 6 divided by 3 equal to 2. Then 18 divided by 2 equal to 9. That is, if a, b and c are three whole numbers, then a minus b minus c is not equal to a minus b minus c, and a divided by b divided by c, which is not equal to a divided by b divided by c. So associativity does not hold true for subtraction and division, while it holds true for addition and multiplication. Hope it is clear to you. We will learn the remaining properties in the next video. If you like this video, please like, share and subscribe. Thank you.